This is the third video of our chemical reaction play series. And this one, we're going to be talking about the law of conservation of mass and what does it mean for chemical reactions? What is really happening at the atomic level that explains why that's true. So in a chemical reaction, according to the law of conservation of mass, matter cannot be created or destroyed. And it's true that, by the way, that matter can become energy and energy can become matter. So in a sense, they can be interchangeable. So you can lose matter. But for that, a nuclear thing has to happen. And in chemistry, that's not going to take place. Not really. So unless you're doing some crazy physics thing, the total amount of matter will be conserved. But even if you were doing some crazy physics thing, the total amount of matter / energy would generally be conserved in the universe. So there's exceptions for that, but we're not going to talk about it right now. If you're curious, ask me about it later. All right. Anyways, the total amount of matter cannot be created or destroyed in a chemical reaction. So whatever you have at the start in terms of the atoms present, the total mass present, has to be there at the end. So the way this is shown at the atomic level in chemical reactions is that the total number of atoms of each type of element that's involved has to be the same in the products and in the reactants. And also, in the chemical equations, you can see that mass is conserved because if there's a certain amount of mass in the reactants, the products will have to have the same amount of mass, right? So the mass of the reactants must be equal to the mass of the products. So you can see that on this example, right? Let's look at it in detail. So you see this methane gas, this is the same equation we talked about in the last video, is reacting with 2 oxygen gas. But then how many total carbons do you see in the left? There's like 1 carbon here. But then on the right side, there's only 1 carbon also inside a carbon dioxide molecule. And then you have 4 hydrogens total on this side right here. On this side, you have 2 hydrogens inside a water molecule, but you have 2 water molecules. So that's going to be 4 hydrogens total. And then you have 4 oxygens total because you have 2 sets of molecules of oxygen gas, each with 2 oxygens. And then you can see there's 2 right here in carbon dioxide, and then 1 in the water molecule, but there's 2 of them, so 2 more there. So 2 plus 2, 4. So that means there are also 4 oxygens. So that means each of the atoms, the total amount in the reactants is the same as the amount in the products. Let's see how that applies to the amount of mass as well. It took 16 grams of methane and then 32 grams times 2 of oxygen gas in order for this reaction to take place. So if you add that up together, that makes 64 on this side plus 16, which is 80 grams total on the left side. And then on the right side, you have 44 grams of carbon dioxide made, and then 2 sets of 18 grams of water. So that means 36 plus 44, which is 50, 80. Yeah. So exactly. The amount of mass on the left side is 80. So the amount of mass on the right side must also be 80. So in that sense, whether you're looking at it in the total amount of mass of the reactants versus products, or in the numbers of elements of each atom, right? The number of atoms of each type, the total is going to be conserved. And that is what is meant by conservation of mass. Let's see this in photosynthesis and cell respiration, right? So it takes 6 carbon dioxides to do this. So it's 6 carbons total. And then there's 6 carbons here in the molecule of glucose that's made during photosynthesis. You have 6 hydrogens times 2 because there's, so that's 12. And there you go, 12 on this side. And then you have 6 times 2 oxygens, which is 12, plus 6 times 1, which is 18. And then here you have 6 plus 12, 18. And so the total amount of mass is conserved because the atoms of each type are there. And since cell respiration is the opposite, it's going to be exactly the same thing. So as you can see, no matter which chemical reaction you look at, if the equation is balanced, like it should be, the total amount of atoms is going to be the same in the reactants and products, right? So what happens to the total number of atoms of each type? It always stays the same. You have 4 hydrogens on the left, you got 4 hydrogens on the right. You got 2 oxygen on the left, you get 2 oxygen on the right. This is the reaction of the formation of water as water burns to form from hydrogen gas burns in the presence of oxygen to form water. So this is a synthesis of water reaction, right? Now, notice that this is obeying the law of conservation of mass because no particles are created or destroyed. All the matter is accounted for. So let's do some practice with this, right? So let's say if you have, you can pause before I give the answer so you can see if you know how to do this. So there's 18.202 grams on the left side of water. And on the right side, you know that you formed 16 grams of oxygen gas. So how much hydrogen gas must be left? Try to figure that out. So hopefully you pause so you can get to try it right. Now notice that means the hydrogen mass, whatever hydrogen gas you have here, by the way, this is the opposite of the reaction that we just looked at. The previous one was water forming. This is water breaking apart. It's called hydrolysis, when electrolysis, which is when water gets fed some electricity through it, and then you can actually see it breaking down into hydrogen gas and oxygen gas. So that reaction must have the rest of its mass here on the products must be accounted for. It has to add up to a total that you had before. So I have to find out what I add to 16 so that I get 18.2. So basically what you have to do is subtract the two amounts to find the 2.02 grams which are left. And that must be the mass of hydrogen gas that gets produced. Because if you add 2.02 to 16, you get back to 18.02. And that's how you know you're right. When you add up the mass of the reactants, it must be equal to the mass of the products. All right, so this is the reaction we just saw a moment ago. Do you remember what the answer was? If not, let's figure it out. We know that 16 plus 64 is 80 grams. That means that there must also be 80 grams in the products. But if you have 44 grams of this, how much do you have to have of that? 36, right? So you have to have 36 grams of the other one. So if you have a problem in a test like this, add up the total mass of the reactants if they don't give it to you already. You just add them together and then figure out how much mass must be there. Then figure out the mass of the one you have, and then the other one must be the difference between that total that has to stay the same. All right. And that's pretty much how you do this. And that was conservation of mass. And we just have one objective left for the next video. See you guys then.